Hi all, welcome to Classroom Fix. So in this video we will see what is algorithmic analysis and how the performance analysis of an algorithm can be done. So analysis of an algorithm can be done in two ways. One is time complexity and the other one is space complexity. Okay, so what is time complexity? Amount of time required for an algorithm during its execution is called time complexity. And space complexity definition kuda easy. Em chestaru time place lo space pattadame. So amount of space required for an algorithm during its execution is called space complexity. So these are the two ways we use in the performance analysis of an algorithm. So there are three types in time complexity. So let's see what are those three types. So three types of time complexities kabatti first the entante best case time complexity. I am writing time complexity as TC. And next the entante average case time complexity. And the third one is worst case time complexity. Okay, so best case time complexity ante enti, if your algorithm requires minimum amount of time for execution, algorithm ki minimum amount of time for execution required aithe it is called as best case time complexity. Minimum amount of time for execution. Worst case ante enti, if it requires maximum amount of time. Maximum amount of time for execution. And your average case time complexity is nothing but if it requires average amount of time for execution. So which requires this average or maximum or minimum time for execution, that is nothing but your algorithm. So the best example to understand this is linear search. So let's see what is linear search. So what is linear search? Linear search means searching of elements in a list one by one until the key element is found in your array. So see, searching elements of a list one by one until key element is found in the array. So this is nothing but your linear search. For example, if I have an array of elements 10, 20, 30, 40, 50. So this is my array of elements, okay? So now I want to do linear search on this and my key element will be 40. So how will I perform this linear search? So I'll compare my key element with the first element, means 10 is not equal to 40. So what I'll do now, I'll compare my key element with the second element. 20 is not equal to 40. Then I'll compare my key element with the third element. 30 not equal to 40. Okay. I'll compare this with my fourth element. 40 is equal to 40, which means my key element is found in the given array, right? So here, to understand it more easily, I'll give you another example. 10, 20, 30, 40, 50. And I was given my key element as 100. So I can understand it without doing any manual part problem solving. I can tell that this element will not be found in this list. If it is not in the list, the array gets exhausted, means the array will be completed, but you'll not find any key element. So what will be your result? You'll write key element not found. So how to find like what is the best case and how you can determine that, okay, this step is called my best case, this step is called my average case, and this step is called my least case or worst case. You can tell it with the help of linear search, and let's see how we can tell that. See, if key element is found at the first position, what you'll call this, then this is called as best case time complexity. How you'll tell this is called best case time complexity? So see, I'm having my array list of elements 10, 20, 30, 40 and 50, and suppose my key element is 10. So within the first step I can determine that my element is found. So I'll compare it with my first element. So నేను కంపేర్ చేస్తుంటే ఏమైపోయింది, నాకు కీ ఎలిమెంట్ ఈజ్ ఫౌండ్. సో కీ ఎలిమెంట్ నాకు ఫస్ట్ స్టెప్లోనే వచ్చేసింది, విచ్ ఇస్ టేకింగ్ ఓన్లీ 1 యూనిట్ ఆఫ్ టైం. సో దిస్ టేక్స్ only 1 unit of time. So this is called best case. Best case ante which takes minimum amount of time during execution, right? So this is called best case. So let's see an example for worst case. Yes, next one is, if key element is found at last position, then this is called as worst case time complexity. So how can you say that it is a worst case time complexity? For example, this is my array 10, 20, 30, 40 and 50, and my key element is 50. So I need to compare it with each and every element in the list. So first I'll do it like, see, I'm comparing 10 with 50, not equal. I'll compare with 20, it is also not equal. Then 30, not equal. Then 40, not equal. Then 50, it is equal. So it is taking 1, 2, 3, 4, 5. So it is taking 5 units of time, and it is also taking maximum time for your execution. Maximum time for execution, and also it is taking 5 units of time. So this is called as worst case time complexity. I hope you understood this one. So now let's see what is an average case time complexity. So average case time complexity ante enti? If key element is found either in second, third or fourth position, then it is called as average case time complexity. This is, I am telling this on the basis of the example. Average time complexity. So let me show you. So this is my list 10, 20, 30, 40 and 50. So this is the list. So my key element will be some 30. So I'm comparing it, 10 not equal to 30. I'm comparing it with my second element 20 not equal to 30, and then again I'm comparing with my third element 30 equal to 30, which means my key element was found, and this is taking 3 units of time. Okay, so it is taking average time for execution. and hence we call it as average case time complexity. So this is how you determine whether it is a best case or a worst case or an average case time complexity with the help of linear search. So in the coming videos, we'll see what is time complexity and what are the methods you follow in time complexity, and then what is space complexity and what are the methods you follow in space complexity, what is frequency count or step count methods, and what is asymptotic notations, and so on. We'll be discussing in the next videos. So I hope you all understood this, and thank you for watching.